Right, our next topic in BGP is configuring BGP. So none of us are new to this. Router BGP followed by the autonomous system number. Who provides this? Our upstream ISP will provide this number, autonomous system number. In autonomous system number also we have private, public, but we don't need to worry about this because our upstream is going to take care of it. Whatever they give, we are going to assign. Nowadays the private autonomous systems are used if you have some WAN connections in between. Otherwise it's not necessary now. What I mean is, you will see private autonomous system numbers when we have an MPLS connection between two sites. So there is no need for public autonomous systems there. So to avoid wasting public autonomous system, our upstream device, our upstream autonomous system will provide us a private autonomous system number. So whatever it is, we are not going to provide some random number. We depend on the upstream service provider to put a number, autonomous system number. Using that number we configure BGP, saying router BGP, let's say 10. 10 is the autonomous system number. Now this number tells two things. One, this router belongs to autonomous system 10. Not only that, this autonomous system number will be compared with the neighbor autonomous system number. If the neighbor's autonomous system number is same like this router's autonomous system number, then the neighbor is considered as internal IGP, means IBGP. If that doesn't match, then it is EBGP. For example, if you see this example here, when this number and the neighbor's autonomous system number is same, it's an IBGP neighbor. See, 10.2.2.2. So this router and this router are IBGP neighbors because they are in same autonomous system. When this differs, then it is EBGP. There is no other command to make known the difference. Routers know the difference between EBGP and IBGP only by comparing the autonomous system number. So that's what I explained here in this whole page. Especially the last paragraph is what I just explained. The second line says the only one instance of BGP can be configured on the router at a single time, meaning you cannot have more than one BGP in a router. If you take OSPF, you can have many OSPF. When you create VRFs, you can have different OSPF for different VRF. But BGP, even if you create VRF, you cannot have more than one BGP for the entire router. Not possible to have one VRF, one BGP. Not at all possible. One router will be part of one. So one BGP will be part of the entire router, physical router. You cannot have more than one OSPF. Sorry, You can have more than one OSP. You cannot have more than one BGP. EIGRP also uses autonomous system number like BGP. But EIGRP allows you to have more than one EIGRP with two different autonomous system number or multiple autonomous system number. In BGP you will not find an option like that, only one BGP. But BGP, though it is only one, it has got different faces. That's why BGP is called as MPBGP, multi-protocol. BGP is one protocol with multiple protocols in it, a big umbrella of protocol. VXLAN, EVPN is because of BGP. No BGP, no EVPN. Layer 3 VPN. No BGP, no layer 3 VPN. VPLS. It's all because of BGP. Segment routing. BGP. Segment routing is one big feature today. VXLAN is another big feature today. It's all because of BGP. So we cannot simply say BGP only one instance, but EIGRP can be many instance. OSPF can be many instance. Okay, it sounds okay, correct. Statements are right, but why BGP is only one per device? Because that's more than enough. You don't need to have more than one BGP. You see, if I have OSPF, for different VRF, I need to create different OSPF to separate one customer's OSPF route from the other. But in BGP, to separate one customer routes from the other, I use that one single BGP with VRF inside. VRF is inside that same BGP. Same BGP, I got different control plane for each customer. I no need to create another BGP for another VRF. One BGP is enough to have multiple customers in it. That's why I said there is no need for more than one instance of BGP. That's what I should say instead of saying only one instance. No. Or you can say one instance of BGP can be sufficient on a router that will be a nice statement. One instance of BGP will be sufficient on a router, so only one is supported. Simple. Third point. The autonomous system number identifies the autonomous system to which the router belongs. We already saw this. And fourth point, the autonomous system number in this command is compared with the autonomous system number listed in the neighbor statement to determine if the neighbor is an internal or external neighbor, IBGP or IBGP. This is the first thing I explained today. Yep. Any question on this page? Let's move on to the next. Now we said router BGP 10 and now we are inside BGP router mode. We need to define the neighbors. The neighbors address is going to become the destination IP address of all BGP communication. Neighbors IP address that you specify here is going to become the destination IP address of all the BGP communication. Neighbors are always configured manually. Neighbors cannot be dynamically learned because BGP is a TCP protocol. BGP cannot send hello packets like OSPF and EIGRP or ISAs. BGP cannot send hello packets. It's a TCP based protocol, application layer protocol. So neighbor command is the one using which you go and specify to whom the BGP session to be established. Next, the second point I already explained. The IP address that is specified is the destination address of the BGP packet going to the neighbor. Next, third point, the router must have an IP path. Very important. If you are specifying an address as a neighbor address, the neighbor address should be pingable. When you ping, the reply should reach. There should be an IP path. So you need to verify this. Very, very important. So it's very simple troubleshooting, you see. I am seeing BGP neighbor always down. It is showing the state is active, meaning it is still trying to form neighbor. When you type show IP BGP summary, it shows always active. It means the neighbor has never come up. Simple. Ping that neighbor address from here. Is it pinging? Later we will learn that we will sometime use Loopback interface to identify peerings, neighbors. If that is the case, then ping using Loopback to Loopback. So make sure the neighbor's IP address is pingable. See, we are learning a lot of things in BGP day by day. For every day BGP topic, if you just think what are all the places there may be a trouble, there may be a mistake done, and how to find them. That's all. There is no need for a separate troubleshooting class for you. This is just beginning, no? From now itself, focus. Today this is what we learned. Now where the mistake may go in this, and how can we identify? The mistake then in this configuration can be identified by typing show IP BGP summary. And when you see neighbor status active or idle, the problem is with the routing table. The problem is with the reachability. The neighbor address might be given wrong. You might have given the neighbor IP address as wrong, or there may not be a route to reach the neighbor. So if you correct this, problem solved. Next, remote AS. You see there is a command remote AS, neighbor IP address and remote AS. Remote AS option to show what AS this neighbor is in. In this output, in this sample configuration, what we see is the remote AS command is used to tell to which autonomous system this neighbor belongs to. You see, this number and this number matches, which means they are of same autonomous system number. They belong to same autonomous system 65101. But still the keyword remote is used. It's the same command for IBGP. Remote. So this remote, you should not take it very serious. You should just compare the autonomous system number, the local and the neighbor's autonomous system number. When they both match, they are IBGP. When they don't match, they are IBGP. So the remote AS keyword is just to tell whether the neighbor is an internal or external. The last command, the remote AS command is used for both external and internal neighbor. See, this is BGP in Cisco device. So Cisco is trying their maximum to explain you their way of configuring BGP. But you will not have this type of, I should confess, you will not have this type of confusion when you configure BGP with other vendor devices. In Cisco, there is this type of confusions are there. You need to know that remote AS is not a command for only IBGP, it is also for IBGP. It's both for internal and external. It's the same remote AS. Internal means local, external means remote, but we don't have any command like a local AS or inside AS. It's always remote AS for both IBGP and IBGP. The other vendors, they use the keyword VPN instance and so on. So they will not use this keyword remote AS. There won't be a confusion in most of the vendors. BGP appliance configurations are very straightforward. Now, if you want to temporarily bring the neighbor down, you no need to remove the neighbor statement. So this is how you configure neighbor statement. To remove, you just put no in front of this. It will remove. So if it is just one line of configuration, you may remove and you can put it whenever you want. But what if a lot of policies are already written for this neighbor, like distribution list, like some route policies with attributes, a lot of things are attached. If you remove this, then it will remove all the policy. Then if you want to put the neighbor back, you need to write all the policy again, which is going to be a lot of administrator overhead. So instead of removing the neighbor, you can simply say neighbor 1.1.1.1 shutdown. Shut it down. Temporarily you are closing the session. Administratively you are saying shutdown. Like you shut down an interface, you are shutting down the BGP session. Now the reason may be you shut down because you want to change some policy, some sort of maintenance. Go do those changes and then say no shutdown. The neighbor is going to come up. Just no in front of the neighbor statement. No neighbor 1.1.1 shutdown. This will be easy for you as an administrator. Then removing the neighbor, going and doing everything from the beginning, the policies for that neighbor, and attaching them, route map in or in route map out, and so on. This is very simple. Shutting down the neighbor temporarily, you can use this shutdown keyword. Now for this last 3-4 pages, we are also seeing peer group. Somewhere here and there we saw peer group. Even here you see it's written peer group. What does this mean, peer group? See, peer is nothing but neighbor, no? Peer and neighbor are same. If you want to shut down group of neighbor in one go, if you want to shut down, or if I want to configure something common for all the neighbors, those neighbors I will be pointing by using a peer group. Neighbor and neighbor IP address. This is just one neighbor. But if I put the list of IP addresses and give a name, peer group neighbor, PQN, and when I, instead of IP address, if I call PQN and configure remote AS, then I have configured remote autonomous system number, remote AS autonomous system number for all these neighbors in just one go. Instead of typing 5 lines, I just typed 1 line. We'll talk about this peer group when we go there. It's coming later. So, should not get confused or anything. Why we are not configuring. We will configure this or this. Means one neighbor or many neighbor. Peer group is many neighbor. Identified with one small name. Now this one, this page provides us something very fundamental knowledge, very basic knowledge about BGP that we should know. We already learned that neighbor IP address will become the destination IP address of all our BGP packet. So destination IP address is the address that you specify under the neighbor statement. Then what will be the source IP address? source IP address will be according to the routing table. It will look into the routing table and know what will be the outbound interface for the destination. That outbound interface IP address will become the source IP address. What does that mean? Let me draw and explain. Right. Now on R1 I'm saying neighbor 2.2.2.2. So R1 is now going to send a packet to the destination 2.2.2.2. What will be the source? Source depends on the routing table. R1 will check the routing table and it finds the 2 network is on E2 direction. E2, exit interface, Ethernet 2, not Ethernet 1 as 0. Ethernet 0 will take you to 11111. Ethernet 3 will take you to 777. But my neighbor is on 22222. So whatever the address that is mentioned here will become the source address of this packet. If it is 2.2.2.1, then that will become the source address 2.2.2.1. Always the outbound interface will define the source. The neighbor address defines the destination. Let's read one more time the paragraph. When creating BGP packet, the neighbor statement defines the destination IP address and the outbound interface defines the source IP address. Let's go to the second paragraph. When BGP packet is received for a new BGP session. Now what we saw now was the sender side, R1 side. Now we are focusing on R2 side. When a BGP packet is received, router 2 is receiving the packet coming from router 1. This is the first BGP packet, meaning a new BGP session. The source address of the packet will be compared with the list of neighbors. If the neighbor address and the source IP address matches, the relationship is going to be established. If no match is found, the packet is ignored. See, when a BGP packet is received for a new BGP session, the source address of the packet is compared to the list of neighbor statement. What does that mean? Let's say .1.1.1. R1 is configured with the neighbor address 10.0.0.2. R2 is configured with the neighbor address 10.0.0.1. Now, we all just learned the first paragraph that the outbound interface will become the source. So when R1 sends the packet, the source address will be 10.0.0.1, the destination will be 10.0.0.2. When this packet arrives on R2, see, that's what I said. When BGP packet is received, the source address of the packet is compared with the list of neighbor statements. If match is found, relationship establishes. Is it matching? Yes, it is matching. When router 2 sends, it will send with 10.0.0.2, which is also matching in R1's neighbor statement. So the neighbor is going to be established. Instead of that, if it is different, like what? Here mistakenly you have given 10. But what is incoming? What is received is 10.0.0.1. The source address of the packet is compared with the list of neighbor statements. Source address 10.0.0.1 is compared with the neighbor statement. No match is found. What will happen? It will ignore. See? Simple. If you know the subject very well, you will also know the trouble. Otherwise, troubleshooting will be a troublesome for you always. Learning is important. Many wants to learn troubleshooting, separate paper for many. No, it should not be like separate. Or many wants to troubleshoot without knowing the subject in depth. No, that's not possible. If I need to troubleshoot my writing pen, simple ball pen, I should know how my pen works. It has got a spring inside, and the refill has got ink inside. If I know that, I'll open the pen. I'll check whether the refill is over or the spring is broken. I can fix it. If I don't know how a pen works, if I simply keep writing with pen and then when trouble comes, I want to troubleshoot. What troubleshoot you will do? You will break the pen because you don't know how to open the pen. Or you will keep on trying to scribble so that ink will come out. Ink will never come out. Ink is already finished. So you don't know that ink need to be refilled. Then you will be keep on scratching, thinking that one luckily it will start writing. How it will write. These rules, if you know, then you will know what's supposed to be there and what need to be corrected. If match is found only, the neighbor can be established. If match not found, the packet is going to be ignored. So that, see the third point, make sure that the source IP address must match the address that the other router has in the neighbor statement. Very important and basic, very first troubleshooting in BGP. Other troubleshooting comes only after you fix this trouble. This is IBGP peering. See the title, IBGP peering example issue. Between router A and D, how many paths? 2 paths. Between C and B, 2 paths. So whenever you got redundant paths, this type of redundant path is available only for IBGP, not for EBGP. Whenever you have redundant paths like this, it is recommended to use Loopback for peering. Why? When I go to A and say my neighbor is 4.4.4.4, I can form neighbor with this way. If this path goes down, still I will have a neighbor via this way. So the neighbor will be available even if one path is available. Instead, if I use physical interface, if I go to router B and say neighbor is 10.2.2.4, if this path goes down, I lose the neighborship. Or if this link goes down, this will go down. The neighbor between A and D will terminate. So whenever you got redundant paths, use only the loopback address to form neighbor. Okay, fine. I have now configured 4.4.4.4 as a neighbor here, 1.1.1.1 as a neighbor here. A will send packet now to the destination what? 4.4.4.4, because that is what configured as neighbor. And what will be the source address? Source address, it will look into the routing table. Routing table says to reach 44444, you go via this interface, let's say Ethernet 1. Go via Ethernet 1. Then Ethernet 1 address will become the source address, 10.1.1.1. Yeah? Yes, no? I said outbound interface. If it goes this way to reach 444, this is what going to be the source address. You remember, when this packet is received on the peer router, the source address will be matched with the neighbor statement. If match found, relationship is established. If match not found, the packet is going to be ignored. You see, the match is not found. 10.1.1.1 is not matching with 1.1.1.1. Is it matching? No. Neighbor statement says your neighbor is 1.1.1.1, but the source address says 10.1.1.1. Are they matching? No, they are not. The neighbor will not come up. So what is the solution? Don't ask me to change the neighbor address on RD. I don't want to change the neighbor address. Why? Because we just learned that using loopback interface address is best whenever you have redundant path. So I cannot change this address to 10.1.1.1. I should not do that. I can only change on the BGP packet. I can only change here. I want this address to be the source address. How can I change that? By default, it will always take the egress interface address, either 10.1.1.1 or 10.3.3.1. Now, how can I change the source address? There is a command called update source loopback. Update source command. You put update source and then say use the loopback interface, maybe loopback 0 or loopback 1, like this. See, there is a redundant path between C and B. Usually it will take the exit interface, but it will not match with the neighbor statement. If you want that to match, then you have to say update source loopback 0, so that router B will take loopback 02222 as a source address, which will match with the neighbor's neighbor list, and the neighbor will be established. So don't forget, if you are using loopback to loopback peering, we have to use this command update source loopback 0. So this command allows BGP process to use the IP address of specific interface. Which interface we are using? Loopback 0 interface as the source IP address of all BGP. So loopback interface is usually used because it is available as long as the router is operational. The physical interface may go down when the link goes down. But the loopback interface will go down only when router goes down. The IP address used in the neighbor command on the other router will be the destination IP address of all BGP updates, and should be we already spoke about that, and it should be loopback interface address. Next, the neighbor update source command is normally used only if IBGP only with IBGP neighbor. See, first of all, you need this only in IBGP scenario. Even here they have very nicely named it as IBGP peering. Commonly, normally, mostly, but there are sometime, you may need even between IBGP. Very rare to have redundant path between IBGP is very rare. See, this is IBGP within same autonomous system, but this is IBGP. This is very rare case. Dual homing, that to back on same routers, but different autonomous system. It's a very rare case. So what do you hear they say is, this is normally used in IBGP scenarios. The address, why it is not used in IBGP? In IBGP, the neighbors must be directly connected. Loopback is not directly connected. Loopback is not directly connected. For IBGP, we learned in the beginning, the first day, the neighbor must be directly connected. When you are forming neighbor using loopback, the neighbors are not directly connected now. So this is one of the reasons why in IBGP we don't use it. But there are some workarounds. If you have a redundant path in IBGP, we can also use loopback to loopback peering in IBGP, which we will be seeing in coming class. So what we have learned in this class is the usage of autonomous system number, how it is important. It is compared with the neighbor's neighbor list. If it is matching, it is IBGP. If it is not matching, then it is IBGP. Peer group is to identify multiple neighbors in one instance. You can configure the neighbor with autonomous system number if you use peer group instead of IP address. And this is one sample configuration output. If you want to temporarily shut down a neighbor, you put neighbor IP address and shutdown keyword. To bring them up, you put no in front of the same statement. This avoids you deleting a neighbor and reconfiguring it. And one important rule that we learned is the BGP packet source address must match with the neighbor's neighbor list, so that when neighbor receives a packet, neighbor will look for the source address to match with its own neighbor list, If match is found, only the neighbor established. If not found, the BGP packet will be simply ignored. So we need to make sure that the source IP address matches with the other router's neighbor statement. At last we learned that whenever we got redundant path, this will be seen mostly in the IBGP scenario. Whenever we form neighbor with redundant via redundant path, whenever we have redundant paths between two BGP neighbor, it is good to use loopback interface instead of physical interface, because physical interface will go down, but loopback interface will never go down. Physical interface will go down if the link fails. And because you got redundant path, when you have neighbor with loopback, alternate paths can be used to keep the neighbor up. But whenever you use the loopback interface, the update source command is needed, otherwise the default exit interface source address will not match with the neighbor's neighbor list. The packet will be ignored. To avoid that, we use the update source command to change the source address of all BGP communication. Mostly loopback interface is what used for this purpose. So we say update source loopback 0. For IBGP we will not do this because IBGP need to be directly connected. Loopback to loopback peering in IBGP needs a lot of workaround because loopbacks are not directly connected. Physical interfaces are the one which is directly connected. In IBGP, this is how the configuration goes: neighbor address, remote AS, the next same neighbor, same address, update source. We'll do a demo on this tomorrow. After that, we will also learn few more that work around in IBGP scenario when you have redundant path, and we'll also do that lab in our next class. Any question on what you learned today?